Hi, welcome. There are several strategies for migrating applications to new environments. In this session, we will discuss a phase-driven strategy for migrating applications to the cloud. I'm Abhishek Mahanty, and I'm a solutions architect with AWS India. The ever-so-evolving AWS Cloud today offers a number of services that you can benefit from. With AWS, you can provision compute power, storage, and other resources, gaining access to a suite of elastic IT infrastructure services as your business demands them. With minimal cost and effort, you can move your application to the AWS cloud and reduce capital expenses, minimize support and administrative costs, and retain the performance, security, and reliability requirements your business demands. As an enterprise, it becomes imperative that you have a cloud strategy in place regardless of whether you're building new applications or aiming to migrate existing applications to the cloud. For new applications, build and design new architectures with the cloud in mind. We have several customers who were quickly able to leverage some of the cloud architecture patterns of implementing elasticity, loose coupling, etc. from ground up. In other words, if you're building a new application, plan for a cloud-ready design. Just like greenfield applications, existing applications can benefit from cloud as well. For existing applications, we recommend building a migration plan and transitioning application by application in a phased manner. A phased migration plan enables organizations to gain experience with the cloud as they begin to transition larger chunks of their infrastructure. Whether you are a startup, small medium business, large enterprise, or a service integrator helping a customer, the strategy remains more or less the same. The step-by-step, phase-driven approach discussed in this session will help you identify ideal projects for migration, build the necessary support within the organization, and migrate applications with confidence. The strategy we recommend consists of 6 phases: cloud assessment phase, proof of concept phase, data migration phase, application migration phase, leverage the cloud phase, and finally the optimization phase. The order of the phases is not important. For example, several companies prefer to skip phase 1, the assessment phase, and dive right into phase 2, where they build a proof of concept or a prototype, or perform application migration before they migrate all their data. So let's have a look at each of these phases. The very first phase is the cloud assessment phase. This phase will help you build a business case for moving to the cloud and will identify the gaps between your current traditional legacy architecture and the next generation cloud architecture. It involves 3 kinds of assessments: financial assessment, security and compliance assessment, and technical assessment. Under financial assessment, you assess the cost of owning and operating a data center or co-located facilities versus employing a cloud-based infrastructure. The AWS Economic Center provides all the necessary tools you need to assess your current IT infrastructure. After you have performed a high-level financial assessment, you can estimate your monthly costs using the AWS Simple Monthly Calculator by entering your realistic usage numbers. If your organization has specific IT security policies and compliance requirements, we recommend that you involve your security advisors and auditors early in the process. It is also important to understand the basics regarding data security. You own the data, not AWS. You choose which geographic location to store the data in. It doesn't move unless you decide to move it. You can download or delete your data whenever you like. You decide if and how you will encrypt your data while it is in transit and while it is at rest. You can set highly granular permissions to manage access of a user within your organization to specific service operations, data, and resources in the cloud for greater security control. Data security can be a daunting issue if not properly understood and analyzed. Hence, it is important that you understand your risks, threats, and then based on the sensitivity of your data, classify the data assets into different categories. This will help you identify which data sets to move to the cloud and which ones to keep in-house. The AWS Security Center provides up-to-date information about certifications and various security best practices. A technical assessment is required to understand which applications are more suited to the cloud architecturally and strategically. You determine which applications to move into the cloud first, which applications to move later, and which applications should remain in-house. You begin by identifying the applications and their dependencies on other components and services. You then create a dependency tree that highlights all the different parts of your applications and their upward and downward dependencies to other applications. This will help you determine which applications can be moved to the cloud quickly. For example, the diagram here gives a snapshot of a company's application assets. A typical diagram should include all the application assets of an organization. For example, ERP systems, CRM systems, payroll, customer-facing web applications, internal IT applications, as well as lower-level shared services such as LDAP servers. In most cases, the business candidates for the cloud are the applications or components that have minimum upward and downward dependencies. So search for applications with underutilized assets, applications that have an immediate business need to scale and are running out of capacity, applications that have architectural flexibility, applications that require global scale. For example, customer-facing marketing and advertising applications, or applications that are used by partners. You will notice very quickly that there are several applications which are no-brainer to move and can be moved today, thereby giving immediate benefits. Some examples are development and test applications, self-contained web applications, batch processing applications, and training applications, to name a few. Identify the tools that you can reuse in the cloud without any modification and estimate how much effort will be required to add AWS support to them. You might be able to reuse most of the system tools or add AWS support very easily. AWS does not force developers to use any particular programming model, language, or operating system. All AWS services expose standard REST web service APIs and provide multiple libraries and SDKs in the programming language of your choice. You're free to use any of our infrastructure services individually or in any combination. Migrating license product. It is important to iron out licensing concerns during the assessment phase. AWS is currently offering 3 different licensing options for you to choose from. Bring your own license, or BYOL, where you purchase the license the traditional way, or use your existing license and apply it to the product which is available as a pre-configured Amazon Machine Image, or AMI. For example, Oracle, Adobe, IBM, and Microsoft have made their software and support available in the AWS cloud using the Bring Your Own License option. The other option is pay-as-you-go, or a utility-style pricing model in which you do not incur any upfront licensing cost and only pay for the resources you consume. ISVs charge a small premium over and above the standard EC2 cost, which gives you an opportunity to run any number of instances in the cloud for the duration you control. Finally, there are some ISVs that have offered their software as a service and charge a monthly subscription fee. They offer standard APIs and web-based interfaces and are fairly quick to implement. For example, Quantivo, Pervasive, and Cast Iron provide a SaaS offering based on AWS. Create a roadmap and a plan. By documenting the dependencies, creating a dependency tree, and identifying the tools that you need to build or customize, you will get an idea of how to prioritize applications for migration, estimate the effort required to migrate them, understand the one-time costs involved, and assess the timeline. Once you are done with identifying your applications for the initial migration, it's time to test the waters with a small proof of concept. The goal of this phase is to learn AWS and ensure that your assumptions regarding suitability for migration to the cloud are accurate. A successful migration largely depends on 3 things: the complexity of the application architecture, how loosely coupled your application is, and how much effort you are willing to put into migration. Now, we have noticed that when customers invest time and resources towards building proof of concept projects, they clearly see the tremendous potential of AWS and are able to leverage its strengths very quickly. So start playing around with some of the AWS services. You can get started right away, and it is simple because once you're logged into, say, a Linux or a Windows instance, that EC2 instance is really no different from the Linux or Windows server that you've been using for years. At a minimum, at the end of the stage, you should know how to use the AWS Management Console and command line tools to do few things like create a S3 bucket, upload an object, create a CloudFront distribution, launch an EC2 instance from an AMI, create EBS volumes, attach EBS volumes, create snapshots, work with elastic IP addresses, launch a RDS-DB instance, and take backups, to name a few. Learn about the various security features provided by AWS, like AWS credentials, authentication and authorization, multi-factor authentication, etc. At a minimum, learn about the AWS IAM features that allow you to create multiple users and manage the permissions for each of these users within your AWS account. Now build a proof of concept that represents a microcosm of your application or which tests critical functionality of your application in the cloud environment. For example, if you're thinking of migrating a web application, you can start by deploying miniature models of all the pieces of your architecture, load balancer, web application, and database with minimal data. In the process, learn how to build a web server AMI, how to set the security group so that only the web server can talk to the application server, how to store all the static files on S3, and how to monitor your application using CloudWatch. In this stage, you can build support in your organization, validate the technology, and test legacy software in the cloud. Perform necessary benchmarks and set expectations. By the end of this stage, you will have far better visibility into what is available with AWS today, and you will get hands-on experience with the new environment, making you a lot more confident. The next phase is the data migration phase, and in my opinion is one of the most critical phases. This phase involves learning about the database and storage options in AWS and strategizing on moving your data into AWS. AWS has a variety of storage options, and each storage option has a unique combination of performance, durability, cost, and interface. When choosing the appropriate storage option, one size does not fit all, and you have to consider all the factors so that your application can scale to your needs appropriately with minimal effort. So for block storage, you have Elastic Block Store or EBS, which provides persistent block level storage for use with EC2 instances. EBS volumes are off-instance network attached storage that persist independently from the running life of a single EC2 instance. After an EBS volume has been attached to an EC2 instance, you are free to interact with it just as you would with a physical hard disk, typically by formatting it with a file system of your choice. You can use an EBS volume to boot an EC2 instance and attach multiple EBS volumes to a single EC2 instance. You also have EC2 local instance store volumes, also called ephemeral drives, that provide temporary block level storage for EC2 instances. When you create an EC2 instance from an AMI, in most cases, it comes with a pre-configured block of pre-attached disk storage. Now, unlike EBS volumes, the data on instance store volumes persists on during the life of the associated EC2 instance and is best used like a scratch volume or RAM disk. For shared file storage, there is EFS or Elastic File System, which supports the NFS version 4 protocol. Multiple EC2 instances can access an EFS file system at the same time, providing a common data source for workloads and applications running on more than one instance. For object storage, there is S3, which is a highly scalable, durable, and available distributed object store designed for mission-critical and primary data storage. Now, S3 provides a simple web services interface that can be used to store and retrieve any amount of data at any time from within the EC2 instance or from anywhere on the web. You can write, read, and delete objects containing from 1 byte to 5 terabytes of data each, and the number of objects you can store in a S3 bucket is unlimited. You have Glacier, which is an extremely low-cost storage service that provides durable storage with security features for data archiving and backup. With Glacier, customers can store their data cost effectively for months, years, or even decades. It enables customers to offload the administrative burdens of operating and scaling storage to AWS, and they don't have to worry about capacity planning, data replication, hardware failure detection and recovery, or time-consuming hardware migrations. You also have various options when it comes to moving data to AWS. There is AWS Storage Gateway, which helps you build a hybrid cloud storage model that connects an on-premises software appliance with cloud-based storage. If you need to move terabytes of data to AWS on a one-time or recurring basis, you can use AWS Import-Export Snowball, which uses secure appliances to transfer large amounts of data into and out of the AWS cloud. AWS also has a variety of database options. You can either run your database on EC2, in which case you manage and administer the database, or you can use RDS, which provides you managed database as a service and supports all the popular relational databases like MySQL, Microsoft SQL Server, Oracle, Postgre, and MariaDB. You can also use Aurora, which is a powerful and cost-effective MySQL-compatible database engine and delivers 5 times the performance of a standard MySQL database. For non-relational workloads, you can use DynamoDB, which is a fast, fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. You can create a database table that can store and retrieve any amount of data and serve any level of request traffic. DynamoDB automatically spreads the data and traffic for the table over a sufficient number of servers to handle the request capacity specified by the customer and the amount of data stored while maintaining consistent and fast performance. It supports both document and key value store models. You have Elasticache, a fully managed caching service which improves the performance of web applications by allowing you to retrieve information from fast managed in-memory caches instead of relying entirely on slower disk-based databases. Elasticache is protocol compliant with Memcached and Redis, the two most popular open source in-memory caching engines. And there is Amazon Redshift, which is a fast, fully managed petabyte scale data warehouse service that makes it simple and cost effective to efficiently analyze all your data using your existing business intelligence tools. It is optimized for datasets ranging from a few hundred gigabytes to a petabyte or more and costs less than $1,000 per terabyte per year, a tenth the cost of most traditional data warehousing solutions. You can move data in the form of virtual machine images as well. AWS VM Import Export enables you to easily import virtual machine images from your existing environment to EC2 instances and export them back to your on-premises environment. This allows you to leverage your existing investments in the virtual machines that you have built to meet your IT security, configuration management, and compliance requirements by bringing those virtual machines into EC2 as ready-to-use instances. You can also export imported instances back to your on-premises virtualization infrastructure, allowing you to deploy workloads across IT infrastructure. You can import Windows and Linux VMs that use VMware, Microsoft Hyper-V, and Citrix Xen virtualization formats into AWS. The next phase is the application migration phase. When it comes to migrating applications to the cloud, there are two main strategies: forklift migration strategy and hybrid migration strategy. In this phase, you will have to decide on which strategy to apply for what type of application. In forklift migration, instead of moving pieces of the system over time, we forklift the applications as they are and move it to the cloud. Self-contained web applications that can be treated as single components and backup archival systems are examples of systems that can be moved into the cloud using this strategy. With this approach, you might be able to migrate an existing application into the cloud with minimal to no changes. And most of the changes involve copying your application binaries, creating and configuring AMIs, setting up security groups, DNS, and switching to RDS databases. Now in the strategy, applications might not be able to take immediate advantage of the elasticity and scalability of the cloud because, after all, you are simply swapping real physical servers with EC2 instances or replacing file servers with S3 buckets or EBS volumes. However, it is important to realize that by using this approach for certain application types, you are shrinking your IT infrastructure footprint and offloading the undifferentiated heavy lifting to AWS. Which means you can now focus on things that actually differentiate you from your competitors. We will have to revisit these applications in the next phases and see how to realize even more benefits of the cloud. Now, not every application can be forklifted into the cloud. So what about the applications which have multiple components or are dependent on internal systems that you do not want to deploy outside your premises? The answer is to approach such scenarios in a hybrid sort of way, wherein you could extend your data center into AWS by using a VPC or a virtual private cloud, which I'll talk about in a moment. A hybrid migration consists of taking some parts of an application and moving them to the cloud while leaving other parts of the application in place. This is considered a low-risk approach to migration, as rather than moving the entire application at once, parts can be moved and optimized one at a time. This reduces the risk of unexpected behavior after migration and is ideal for large systems that involve several applications. This strategy can also be used to integrate cloud applications with other cloud-incompatible legacy applications, for example, mainframe applications or applications that require specialized hardware to function. Now, as far as connectivity is concerned, you can connect your data center to AWS in more ways than one. You can set up a hardware-based IPsec VPN tunnel between your data center and your VPC. This way, your data is transferred over an encrypted channel. Or you can use AWS Direct Connect to establish a dedicated network connection between your premises and AWS. This, in many cases, can reduce your network costs, increase bandwidth throughput, and provide a more consistent network experience than internet-based connections. Amazon VPC lets you provision a section of the AWS cloud where you can launch AWS resources in a virtual network. You have complete control over your virtual networking environment, including selection of your own IP address range, creation of subnets, and configuration of route tables and network gateways. You can easily customize the network configuration for your VPC. For example, you can create a public-facing subnet for your web servers that have access to the internet and place your backend systems such as databases or application servers in a private-facing subnet with no internet access. You can leverage multiple layers of security, including security groups and network access control lists, to help control access to EC2 instances in each subnet. Additionally, as I mentioned earlier, you can create a VPN connection between your data center and your VPC and leverage the AWS cloud as an extension of your corporate data center. Leverage the cloud phase. After you have migrated your application to the cloud, it is advisable to invest time and resources to determine how to leverage additional benefits of the cloud. Often we see customers migrating to cloud but miss out on leveraging the key benefits. So leverage on the key tenets. Implement elasticity. If your traffic spikes have a very defined pattern or are based on certain known events, you can proactively scale by calling APIs. Or you can use auto-scaling, which enables you to set conditions for scaling up or down your EC2 usage. When one of the conditions is met, auto-scaling automatically applies the action you have defined. Basically, it allows you to scale based on the actual demand. With just a few clicks or command line calls, you can create a CloudFront distribution for any of your S3 buckets. This will edge cache your static objects closer to the customer and reduce latency. Now, cloud provides you with a scriptable infrastructure, so you can completely automate your software development and deployment lifecycle. You could manage your development, build, testing, staging, and production environments by creating reusable configuration tools, managing specific security groups, and launching specific AMIs for each environment. Automating your upgrade process in the cloud is highly recommended at this stage so that you can quickly advance to newer versions of the applications and also roll back to older versions when necessary. With the cloud, you don't have to install new versions of software on old machines, but instead throw away old instances and relaunch new, fresh, pre-configured instances. If upgrade fails, you simply throw it away and switch to new hardware with no additional cost. Create a business continuity plan and achieve high availability by leveraging multiple availability zones. For those who are not aware, availability zones are a set of data centers in multiple distinct locations that are engineered to be insulated against failures in another availability zone. We provide inexpensive low latency network connectivity across availability zones, and every AWS region comes with at least 2 availability zones. You can create a much higher availability environment by cloning the entire architecture and replicating it in a different availability zone, or by simply using multi-AZ deployments for services like RDS. Hardened security. At every stage of your migration process, you should implement the right security best practices. Things like safeguard your AWS credentials, timely rotate your AWS access credentials, and immediately rotate if you suspect a breach. Leverage multi-factor authentication or MFA. Restrict users to AWS resources. Create different users and groups with different access policies using IAM features to restrict and allow access to specific AWS resources. Leverage the power of security groups in EC2. Protect your data by encrypting it at rest and in transit. And adopt a recovery strategy. Create periodic EBS snapshots and RDS backups. Occasionally, test your backups before you need them. Now, once you're finally done with migration, don't forget to ensure that you optimize costs in an ongoing manner. Since you only pay for the resources you consume, you should strive to optimize your system whenever possible. A small optimization might result in thousands of dollars of savings in your next monthly bill. Following are some of the things you can do to optimize costs. Understand your usage patterns and manage your cloud resources more effectively. terminate your underutilized instances, or move them to a smaller instance size. For steady state workloads, for example, database servers, domain controllers, etc., invest in reserved instances. Depending upon the reserved pricing model and term, this can translate into substantial savings. Improve performance and efficiency. The AWS cloud provides utility-style pricing. You are billed only for the infrastructure that has been used. You are not liable for the entire infrastructure that may be in place. This adds a new dimension to cost savings. You can make very measurable optimizations to your system and see the savings reflected in your next monthly bill. For example, a caching layer can reduce your data requests to your database substantially, thereby allowing you to use a smaller instance for your database. Improving performance of the application running in the cloud might also result in overall cost savings. For example, if your application is transferring a lot of data between EC2 and your private data center, it might make sense to compress the data before transmitting it over the wire. This could result in significant cost savings in both data transfer and storage. Monitor resources regularly. Implement telemetry in your cloud applications so it gives you the necessary visibility you need for your mission-critical applications or services. It is important to understand that end-user response time of your applications depends upon various factors besides the client infrastructure: ISP connectivity, third-party services, browsers, and hops, just to name a few. Measuring and monitoring the performance of cloud applications will give you the opportunity to proactively identify any performance issues and help you diagnose the root causes so you can take appropriate actions. Monitor your AWS bill, S3 and CloudFront access logs periodically. Implement various cloud best practices. This will help you to create not only a highly scalable application conducive to the cloud, but will also help you create a more secure and elastic application. Trusted Advisor. Trusted Advisor is an online resource that will help you reduce cost, increase performance, and improve security by optimizing your AWS environment. Like your customized cloud expert, AWS Trusted Advisor analyzes your AWS environment and proactively provides best practice recommendations in 4 categories: cost optimization, performance security, and fault tolerance. Define your success criteria. Remember that cloud is not just about saving money. It's a much more powerful paradigm and gives you and your developers plenty of benefits like developer productivity due to reproducibility, business agility, reduced time to market, automatic hardware upgrades, to name a few. If your company decides to move away from commercial development tools to open source, all you have to do is turn off, dispose of the hardware, and start new. Before migrating to cloud, define your success criteria, and after migration is complete, ensure that it has been met. Now, before we finish, I thought it would be useful to talk about some of our existing customers who have found migration strategies for their cloud deployment and over a period of time have moved to AWS. NDTV is a premier news channel in India. What NDTV did a few years ago was to start a dedicated portal to serve as a video repository for all their content. Now, when they had formulated this idea, there was just no way they could have predicted the demand or the hits this website would receive and the amount of resources they would require to keep it up. Now, they had decided that they will go with cloud ground up. And today, this site actually serves about 8.5 million video on demand requests each month. They used this project as a learning exercise and then over multiple phases moved their other properties like ndtv.com, NDTV Profit, NDTV Social to AWS. So, if you remember, towards the beginning of my presentation, I mentioned about building a cloud strategy. This is a great example of that. They used a greenfield application deployment on the cloud and then migrated existing sites in a phased manner. Another example I want to mention is InMobi. They're a large independent mobile ad serving platform. So basically they provide services for ad developers, publishers, and advertisers. InMobi already had few existing data centers around the world, and the scale at which they were growing required setting up of additional data centers very quickly. So moving to the cloud was the logical step, and they decided to leverage AWS. They started by extending some of their data centers into AWS using Direct Connect so that their existing data centers were seamlessly connected. And then, over a period of few months, they started picking and choosing applications to migrate to the cloud. The strategy was to constantly keep moving applications one by one to the cloud, optimizing each of them, and then migrating the next workload. Since they were using Direct Connect, they were able to even move applications that had dependencies with their current data center deployments. Among the many benefits they gained on AWS, one key aspect they were able to leverage well was the geographical distribution of their deployments to serve their customers as per their end locations. As you know, with AWS, you get the flexibility of choosing the region where you want to deploy your workloads. InMobi can now have a part of their infrastructure, say in Singapore, to serve their APAC customers and have deployments in other geographies, say US East, to serve their customers in North America. Going on building additional data centers in each of these locations would have been a much more complex and a time-consuming process for them. So, just to recap, it's important to have a cloud strategy in place regardless of whether one is building new applications or aiming to migrate existing applications to the cloud. The AWS cloud provides you elasticity, agility, and reliability to your enterprise. To take advantage of the benefits of AWS cloud, enterprises should adopt a phase-driven migration strategy and try to take advantage of the cloud as early as possible. Whether it is a typical 3-tier web application, nightly batch process, or complex backend processing workflow, most applications can be moved to the cloud. The phase-driven approach discussed in this session will help you identify ideal projects for migration, build the necessary support within the organization, and migrate applications with confidence. After you move your first application to the cloud, you will get new ideas and see value in moving more applications into the cloud. If you need more details about migration strategies, you can check out our white paper on our public website, aws.amazon.com/whitepapers. Now, AWS provides a wealth of learning resources. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced labs. Attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. Validate your technical expertise with AWS and use practice exams to help you prepare for the AWS certification. You can get more information at aws.amazon.com/training. That's pretty much it from my side. Thank you for attending the session. We hope you found it interesting. Do provide us with your feedback and let us know how we can improve the event experience for you in the future. Thanks again.